Hello, welcome to this video. Have you been asked what quantum computing is, or where it is used, or how it works? If you have these questions, then welcome to this video. In recent years, we have seen a lot of progress in the world of technology. In order to continue our progress, we must have good facilities. For example, when scientists want to do the strain of molecules during photosynthesis, they can't do experiments with computers that aren't very powerful. Here, quantum computing comes to the aid of scientists and help them a lot in the experiments, which if we want to do these experiments with normal computers, it will take several months, but with quantum computing, we can do them in a minimum of a day. Now that you have seen how much quantum computing can help us in progress, let's explain what quantum computing is. Quantum computing is a type of computing that uses quantum machines principles to perform operations on data. In traditional computing, data is processed using bits, which are either 0 or 1. In contrast, quantum computing using qubits, which can be in a superposition of both 0 and 1 simultaneously. This allows quantum computers to perform certain types of calculations much faster than traditional computers. Quantum computers can be used to solve complex problems in fields such as cryptography, chemistry, and machine learning. However, building and programming quantum computers is still a very challenging task, and they aren't yet widely available for general use. How does a quantum computer work? A quantum computer is a type of computer that uses the principles of quantum machines to perform certain computations that are difficult or impossible for classical computers. In classical computers, data is processed using bits, which can represent either 0 or 1. However, in quantum computers, data is represented using quantum bits, or qubits, which can represent both 0 and 1 at the same time. The basic building block of a quantum computer is the quantum bit or qubit. A qubit can be in two states at once, a property known as superposition. This means that a qubit can represent both 0 and 1 simultaneously. Additionally, qubits can also be entangled, which means that the state of one qubit is dependent on the state of another qubit. Quantum computers have the potential to solve certain problems much faster than classical computers. For example, they can be used to factor large numbers much more efficiently, which could have significant implications for cryptography and cybersecurity. Additionally, quantum computers can be used to simulate complex quantum systems, which could have important applications in fields such as chemistry, materials science, and drug discovery. Where are quantum computers used? Quantum computers are still in their early stages of development, but they have the potential to revolutionize many fields by solving problems that are currently intractable for classical computers. Here are some potential areas where quantum computers may be used. 1. Cryptography. Quantum computers could break many of the existing encryption techniques used to secure online communication and data storage. However, quantum computers could also be used to create new, more secure forms of encryption. 2. Drug design. Quantum computers could be used to simulate the behavior of complex molecules, allowing for more efficient drug design and discovery. 3. Optimization. Quantum computers could be used to solve optimization problems, such as finding the most efficient routes for logistics or minimizing financial risk. 4. Machine learning. Quantum computers could be used to train more powerful machine learning models, which could have applications in fields such as image recognition and natural language processing.